Welcome to Milky Narratives. Tonight, leave behind the noise of the waking world, relax your mind, and drift with me into the quietest mysteries of the universe. 1. The places where reality breaks down. Everything you have ever experienced follows rules. Drop a glass and it falls. Strike a match and it burns. Look into a mirror and your reflection stares back. From the smallest grain of sand to the largest galaxy, the universe seems to obey an invisible set of laws so reliable that we rarely stop to question them. Gravity pulls downward. Time moves forward. Cause comes before effect. These rules feel permanent. They feel absolute. But what if they aren't? What if there are places where the universe itself begins to forget its own instructions? Places where space twists into impossible shapes, where time stretches until it almost stops, where light can become trapped forever, and where the greatest scientific theories ever written suddenly refuse to agree with one another. There are regions of the cosmos where our equations simply break apart, where even the brightest physicists quietly admit, we don't know. Not because we haven't looked hard enough, but because reality itself becomes stranger than anything our minds evolved to understand. Tonight, we begin our journey at the very edge of knowledge. Not into fantasy, not into science fiction, but into places that almost certainly exist. Places where mathematics still works. Until suddenly, it doesn't. Where the universe stops giving clear answers, and where every discovery only deepens the mystery, because somewhere beyond the familiar stars lies a boundary unlike any ocean or mountain. Cross it, and reality itself begins to unravel. For most of human history, we believed the universe was understandable. The sun rose each morning. The moon followed its predictable path. The seasons returned with comforting regularity. Even when ancient civilizations could not explain why these things happened, they trusted that hidden patterns existed beneath the surface. Centuries later, science rewarded that trust. Isaac Newton revealed that the same gravity causing an apple to fall also guided the moon around Earth. Suddenly, heaven and earth obeyed the same law. Hundreds of years afterward, James Clerk Maxwell united electricity and magnetism into a single, elegant theory. Then came Albert Einstein, who transformed gravity from an invisible force into the gentle curvature of space and time themselves. With every generation, humanity became more confident. The universe appeared astonishingly logical, almost elegant, as though every mystery simply waited for someone clever enough to solve it. For a while, that confidence seemed justified. Then scientists began looking deeper, far smaller than atoms, far larger than galaxies, far closer to the beginning of time itself. And something unexpected happened. The universe stopped behaving politely. Instead of becoming simpler, it became increasingly strange. Quantum particles refused to occupy definite positions until measured. Empty space was no longer empty. Time itself flowed differently depending on gravity and motion. The closer scientists looked, the more reality resembled something entirely unlike everyday experience. It was as though we had spent centuries exploring the calm shoreline of an immense ocean, only to discover impossible storms waiting beyond the horizon. Perhaps nowhere illustrates this better than a black hole. Most people imagine black holes as giant cosmic vacuum cleaners, endlessly swallowing everything nearby. Reality is both quieter and far more unsettling. A black hole forms when an extremely massive star exhausts its nuclear fuel. Without the outward pressure created by fusion, gravity finally wins. The star collapses inward, faster, smaller, denser. Eventually, so much mass occupies such a tiny volume that something extraordinary happens. The escape velocity exceeds the speed of light. From that moment onward, nothing, not light, not matter, not information as we currently understand it, can escape once it crosses the event horizon. To an outside observer, the black hole appears strangely simple. It has a mass, a spin, an electric charge. Almost everything else about the original star disappears from view. Nature seems to erase nearly all the complexity that once existed. Yet, the true mystery lies deeper, far beneath the event horizon. According to Einstein's theory of general relativity, gravity continues crushing matter into an infinitely tiny point known as a singularity, infinite density, infinite curvature of spacetime, infinite gravity. Whenever physicists encounter infinity inside an equation describing the real universe, alarm bells begin ringing. Infinity usually signals that something fundamental has gone wrong, not necessarily with reality, but with our understanding of it. Imagine building a map that suddenly labels one location simply as, beyond this point, the map no longer works. That is essentially what the singularity represents. General relativity carries us confidently toward the center of a black hole, then quietly admits defeat. Normally, this would not seem unusual. Scientific theories often have limits. Newton's equations fail at extremely high speeds. Einstein improved upon Newton. Perhaps another theory will eventually improve upon Einstein. The difficulty is that another theory already exists, quantum mechanics, and it is every bit as successful. Quantum theory describes atoms, particles, radiation, and the microscopic universe with astonishing precision. Its predictions have been verified countless times. Modern electronics, lasers, and computers all depend upon it. Yet inside a black hole, general relativity and quantum mechanics begin making contradictory demands. One treats gravity as smooth geometry. The other insists reality behaves according to quantum uncertainty. Each works brilliantly on its own. Together, they refuse to cooperate. It is rather like owning two beautifully accurate maps. One perfectly describes every road, the other perfectly describes every river. Yet when placed together, the mountains appear in completely different places. Both cannot simultaneously be complete. Somewhere, something remains missing. Physicists have spent decades searching for a deeper framework capable of uniting these two remarkable theories. Some investigate string theory, proposing that the smallest building blocks of nature are not point-like particles, but unimaginably tiny vibrating strings. Others explore loop quantum gravity, suggesting that space itself may be woven from discrete quantum loops rather than flowing continuously. There are additional ideas as well. None has yet achieved definitive experimental confirmation. The universe keeps its deepest architecture carefully hidden, and perhaps nowhere hides it more successfully than within black holes. Reality becomes equally mysterious near the very beginning of time. If we follow the expansion of the universe backward, galaxies grow closer together. Temperatures rise, density increases. Eventually, every observable region appears compressed into an unimaginably hot, compact state. Mathematics again approaches infinity. Once again, our equations fail. We often speak casually about the Big Bang as though it were simply an explosion. In truth, scientists understand remarkably little about the precise instant at which the universe began. What happened before? Did before even exist? Did time itself emerge alongside space? Current physics offers intriguing possibilities, but no universally accepted answer. The beginning of everything remains one of the greatest unsolved mysteries in science. Even empty space turns out to be far stranger than its name suggests. Imagine removing every atom, every molecule, every photon of light, every particle you can think of. Common sense would call the result nothing. Quantum physics gently disagrees. According to modern theory, the vacuum constantly seethes with fleeting quantum fluctuations. tiny particle-antiparticle pairs briefly appear before vanishing again. Energy ripples through apparent emptiness. Absolute nothingness may not truly exist anywhere in nature. The universe seems unwilling to remain perfectly empty. Even silence contains whispers. There are places where time itself becomes uncertain. Earlier, we mentioned that gravity changes the flow of time. This is no longer merely theoretical. Modern GPS satellites must account for Einstein's predictions because time passes slightly faster for them than for clocks on Earth's surface. Without those corrections, navigation systems would quickly become inaccurate. Near extremely massive objects like neutron stars or black holes, the effect grows dramatically stronger. An astronaut orbiting close to a black hole might experience only a few hours while decades pass elsewhere. To that traveler, nothing unusual happens. Their heartbeat remains steady. Their thoughts proceed normally. Only when they return would they discover that generations had quietly come and gone. Time does not simply move at different speeds. It becomes personal, local, almost subjective. Perhaps the most humbling realization is not that reality becomes strange. It is that reality was always strange. Our everyday lives occupy only a tiny, comfortable corner of the universe. Like fish unaware of the ocean surrounding them, we evolved to understand falling stones, flowing rivers, and familiar daylight. The deeper structure of existence never needed to make intuitive sense to our ancestors. It only needed to allow them to survive. Science has gradually pulled back that comforting curtain. Behind it lies a cosmos far richer than common sense ever imagined. A universe where empty space possesses energy, where time bends, where gravity shapes geometry, where particles behave like waves, where black holes challenge every equation we possess, and where the greatest discoveries often begin with three remarkably honest words: we don't know. Perhaps that is not a weakness of science. Perhaps it is its greatest strength, because every unanswered question is an invitation. Every broken equation marks the edge of the map. And somewhere beyond those unfinished equations, hidden inside places where reality itself seems to falter, the universe patiently waits, not resisting discovery, simply asking us to keep wondering. One mystery at a time. 2. The light we were never meant to see. Somewhere above you tonight, hidden behind every star, every galaxy, and every glowing nebula, there is an ancient light that has been traveling through space for nearly the entire history of the universe. It began its journey long before the Earth existed, long before the Sun was born, long before the Milky Way acquired its familiar spiral shape. In fact, this light is older than every star you have ever seen, older than every planet, older than every black hole formed from dying suns. It comes from a time when the universe itself was still young, a time before galaxies illuminated the darkness, a time before starlight existed at all. For billions of years, this ancient glow crossed the expanding cosmos completely unnoticed. It slipped between galaxies, passed through enormous cosmic voids, traveled across distances so vast that human language struggles to describe them. And eventually, a tiny fraction of that ancient light arrived here, at Earth, at the exact moment when a species capable of wondering about its origins happened to exist. It is one of the greatest coincidences in cosmic history, or perhaps one of the universe's greatest gifts. Because hidden within that ancient light is a message, not written in words, not encoded by intelligence, but preserved by nature itself. A message from a time so distant that the universe was barely beginning its story. Tonight, we follow that message backward through time, toward the oldest light we can ever see, and toward a moment when the universe was still learning how to become a universe. When most people imagine looking into space, they imagine looking outward, across vast distances, toward distant stars and galaxies. Astronomers see something slightly different. When they look outward, they are also looking backward, because light takes time to travel. The moon appears as it was about 1 second ago. Sunlight shows the sun as it existed 8 minutes earlier. The nearest star beyond our solar system appears as it was more than 4 years ago. The farther we look, the deeper into history we travel. A galaxy 1 million light-years away appears 1 million years younger. A galaxy 1 billion light-years away appears 1 billion years younger. Modern telescopes function almost like time machines, not by moving through time, but by receiving ancient light that has spent eons crossing the universe. Every astronomical observation is, in some sense, an observation of the past. Naturally, this raises an intriguing question. How far back can we see? Can we observe the first stars, the first galaxies, the very beginning itself? For many years, astronomers assumed that increasingly powerful telescopes would eventually reveal the universe's ultimate starting point. But reality turned out to be far stranger. There is a wall, not a physical wall, not an object, but a limit beyond which ordinary light cannot show us anything. To understand why, we must travel back nearly 14 billion years, to a universe completely unlike the one we know today. Immediately after the Big Bang, the universe was unimaginably hot. Temperatures were so extreme that atoms could not exist. Matter existed as a dense plasma, a glowing mixture of free electrons and atomic nuclei. Light filled every direction, yet paradoxically, the universe was completely opaque. Imagine standing inside a dense fog. Light exists all around you, but you cannot see very far because photons constantly collide with tiny droplets of water. The early universe behaved similarly. Photons could not travel freely. Every attempt to move was interrupted by collisions with charged particles. The cosmos glowed brilliantly, yet nothing could be seen through it. The universe spent hundreds of thousands of years trapped inside its own radiant fog. Then something remarkable happened. As space expanded, temperatures gradually fell. Eventually, about 380,000 years after the Big Bang, conditions became cool enough for electrons and nuclei to combine into stable atoms. Hydrogen formed, helium formed. For the first time, photons no longer collided constantly with free particles. Suddenly, light could travel freely. The fog lifted. The universe became transparent, and an enormous flood of radiation escaped into space. Those photons began a journey that continues even today. They are still traveling, still spreading outward, still carrying information about that ancient moment. This event is known as recombination, although many astronomers poetically describe it as the moment the universe became visible, its first clear snapshot, its earliest surviving photograph. The light released during that ancient era is called the cosmic microwave background, often abbreviated as the CMB. At first glance, it seems almost disappointing. It is not colorful. It is not dramatic. It does not resemble the dazzling images captured by modern space telescopes. Today, after billions of years of cosmic expansion, that ancient radiation has stretched into microwave wavelengths invisible to human eyes. Special instruments are required to detect it. Yet this faint glow may be the most important light in the universe, because it is the oldest light we can ever observe directly. Everything beyond it remains hidden behind the primordial fog. The CMB represents the furthest visual horizon in existence, the ultimate edge of observable history. What makes this ancient radiation so extraordinary is not merely its age, it is what it contains. Imagine finding a photograph taken shortly after the birth of an entire civilization. Every detail would be priceless. Every face, every building, every tiny clue. The cosmic microwave background serves a similar purpose for cosmologists. Embedded within its faint patterns are tiny temperature variations, differences of only a few millionths of a degree. At first, these fluctuations seem insignificant, yet they reveal something astonishing. They are the seeds from which everything eventually grew. Every galaxy, every star, every planet, every living creature, including us. Those tiny variations mark regions where matter was slightly denser than average. Gravity slowly amplified those differences over billions of years. The denser regions attracted more material. Galaxies formed. Clusters emerged. The magnificent cosmic web we explored earlier gradually appeared. Without those tiny imperfections, the universe might have remained an almost featureless sea of gas forever. No galaxies, no stars, no observers wondering how it all began. In a strange way, the cosmic microwave background is the oldest family photograph humanity possesses. Not of people, not even of stars, but of the universe itself. When scientists map the CMB across the entire sky, they are creating a portrait of creation's infancy, a picture taken when the cosmos was less than 100,000th of its current age. No telescope can show us anything older using ordinary light. This ancient glow represents the earliest chapter still visible. Everything before remains hidden behind a veil. Yet perhaps the most astonishing fact is that this ancient light surrounds us constantly. It fills every direction. At this very moment, photons from the dawn of the universe are passing through your room, through your body, through Earth itself. Every second, relics from the birth of the cosmos quietly stream through space unnoticed. You cannot see them. You cannot feel them. Yet they are here, a permanent reminder that the universe carries its earliest memories everywhere it goes. In 1964, two radio astronomers named Arno Penzias and Robert Wilson accidentally discovered this ancient glow. They were attempting to eliminate an annoying background signal from a large antenna. No matter where they pointed it, the noise remained. They checked their equipment. They examined possible interference. They even cleaned pigeon droppings from inside the antenna, suspecting it might be the source of the problem. Nothing worked. Eventually, they realized the signal was real. It came from the sky itself. What seemed like unwanted noise turned out to be one of the greatest scientific discoveries of the 20th century. They had detected the afterglow of creation, the universe whispering across nearly 14 billion years. Perhaps that is what makes this ancient light so moving. Unlike distant galaxies, it was never meant for us. No intelligence created it. No message was intentionally sent. It exists simply because the universe once passed through a particular moment in its history. And yet, billions of years later, it arrived precisely when curious minds were ready to listen. It feels almost like finding a letter written before language existed, a message without an author, a memory without a storyteller. Earlier tonight, we explored places where reality begins to break down. Black holes, singularities, the boundaries of understanding. Now we find ourselves standing at a different boundary, not the edge of physics, but the edge of visibility itself. Beyond the cosmic microwave background lies a universe we cannot see directly, a realm before the first light escaped, a chapter before the first photograph. For now, it remains hidden, but the ancient glow continues reaching us, patiently, silently, carrying news from a time before stars illuminated the heavens, before galaxies filled the darkness, before the universe became recognizable. A message from the oldest dawn imaginable, still traveling, still arriving, one ancient photon at a time. 3. The invisible architecture of the cosmos. Imagine walking into a magnificent cathedral. Towering stone columns stretch toward the ceiling. Elegant arches support enormous walls. Every window, every sculpture, every beam seems carefully placed according to a hidden design. Now imagine that somehow, the entire stone framework suddenly becomes invisible. The stained glass remains suspended in midair. The ceiling floats effortlessly above your head. The walls stand without support. You can still see the beautiful decorations, but the structure holding everything together has completely disappeared. At first, it would seem impossible. And yet, that is astonishingly close to the universe we actually live in. The galaxies you admire through telescopes, the glowing spirals, brilliant star clusters, and enormous cosmic clouds are only the decorations. The true framework supporting them cannot be seen. It emits no light, reflects no light, absorbs almost no light. No telescope has ever photographed it directly. No spacecraft has ever touched it. No human being has ever observed it with their own eyes. And yet, without this invisible architecture, galaxies like our own Milky Way might never have formed at all. Entire clusters of galaxies would drift apart. The magnificent cosmic web stretching across billions of light years would simply not exist. Tonight, we leave behind the visible universe, not because it ends, but because most of it has always been hidden. A silent framework stretching through space, patiently holding together the greatest structures ever created, while remaining almost completely invisible. When you step outside on a clear night, the stars seem to tell a simple story. Bright objects float in empty darkness. The spaces between them appear vacant. A galaxy looks like an island of light surrounded by endless nothingness. For centuries, that seemed perfectly reasonable. Astronomers carefully mapped the visible heavens. They measured stars, counted galaxies, estimated their masses. Piece by piece, the universe appeared understandable. Then the numbers stopped making sense. In the early 20th century, astronomers began studying how galaxies move inside enormous galaxy clusters. According to Newton's laws, objects orbit faster when more mass is present. The calculation is straightforward. Measure the visible stars, estimate their total mass, predict how quickly galaxies should travel. Simple. Except reality refused to cooperate. The galaxies were moving far too quickly. So quickly, in fact, that the clusters should have flown apart long ago. Something invisible seemed to be providing extra gravity. At first, many scientists suspected simple errors. Perhaps the observations were incomplete. Perhaps telescopes had missed enormous numbers of faint stars. Perhaps the calculations needed refinement. But decade after decade, the discrepancy remained. The universe insisted on hiding something. The mystery deepened in the 1970s. Astronomer Vera Rubin carefully measured how stars orbit within spiral galaxies, including systems remarkably similar to our own Milky Way. Common sense suggested that stars near the galactic center should orbit rapidly, while those farther away should move much more slowly. This is exactly how planets behave in our solar system. Mercury races around the Sun. Neptune moves much more leisurely. Gravity weakens with distance. The same pattern should appear inside galaxies, but it didn't. Instead, stars far from galactic centers continued orbiting almost as quickly as stars much closer in. It was as though every galaxy contained an enormous invisible halo extending far beyond its glowing edge. A hidden mass, a silent companion, one that no telescope could see. Rubin's observations became some of the strongest evidence that the visible universe represents only a small fraction of what actually exists. Although today, astronomers call this mysterious substance dark matter. The name sounds dramatic, almost mysterious, yet in many ways it is surprisingly humble. Dark simply means it does not interact with light in the ordinary ways familiar matter does. It neither shines nor reflects. It remains transparent across the electromagnetic spectrum. If Earth somehow passed through a cloud of dark matter, and according to current understanding, it almost certainly does continuously, we would notice almost nothing. The particles would quietly drift through our bodies, our oceans, even the planet itself, interacting so weakly that billions would pass through every second without leaving a trace. Dark matter is not hidden because it is far away. It is hidden because it is astonishingly elusive. Remarkably, everything we have ever touched belongs to a surprisingly small minority. Every mountain, every ocean, every tree, every person, every planet, every star, even every galaxy visible in the night sky. Together, all of ordinary matter makes up only about 5% of the universe's total energy content. The remaining 95% belongs to mysteries. Roughly 27% appears to be dark matter. Most of the rest is something even stranger called dark energy, which we will visit later in our journey. The realization is quietly astonishing. The universe you see is not the whole universe. It is only the illuminated surface of something vastly larger. If dark matter cannot be seen, how do astronomers know it exists? The answer lies in gravity. Earlier tonight, we explored how gravity bends time itself. Here we discover that gravity also reveals invisible objects. Imagine watching leaves swirling across a quiet pond. Although the wind itself remains invisible, the leaves reveal its presence. Astronomers use galaxies in much the same way. They observe how visible matter moves. When motion exceeds what visible mass alone can explain, unseen gravity must be contributing. Gravity becomes the fingerprint of invisible structure. One of the most beautiful demonstrations involves gravitational lensing. Einstein predicted that gravity bends light. Normally, we imagine light traveling in perfectly straight lines. Yet massive objects curve the fabric of space-time itself. Light simply follows those curves. When enormous concentrations of dark matter lie between Earth and distant galaxies, they distort the paths of incoming light. Galaxies behind them appear stretched, twisted, sometimes duplicated into glowing arcs. Astronomers carefully analyze these distortions to create maps of invisible mass. The resulting images are extraordinary. Bright galaxies trace only part of the story. Around them, enormous clouds of unseen gravity reveal vast structures extending far beyond anything visible. It is rather like discovering the outline of an invisible mountain because rivers quietly flow around it. As observations improved, an even grander picture emerged. Dark matter does not exist merely as isolated halos around galaxies. It forms an immense cosmic web stretching across the observable universe. Imagine billions of galaxies arranged along delicate threads, while enormous empty voids lie between them. This web spans hundreds of millions of light years. Galaxies gather where invisible filaments intersect. The glowing universe follows an unseen blueprint. Computer simulations produce this remarkable structure only when dark matter is included. Remove it, and galaxies struggle to form. The magnificent universe we know simply never appears. Invisible architecture quietly guides visible creation. In many ways, dark matter behaves like the scaffolding used while constructing a great cathedral. Visitors admire the finished stained glass windows, the soaring arches, the polished stone. Few ever think about the temporary framework that allowed everything else to take shape. Similarly, shortly after the Big Bang, dark matter began gathering into enormous halos under the influence of gravity. Ordinary gas slowly fell into these invisible structures. Stars ignited, galaxies emerged, clusters assembled. The luminous universe grew inside an already existing invisible framework. Long before galaxies decorated the cosmos, the architecture was quietly waiting. And yet, despite decades of research, one profound mystery remains. What exactly is dark matter? Scientists have proposed many possibilities. Perhaps it consists of entirely new elementary particles, unlike anything contained within the standard model of particle physics. Experiments deep beneath mountains and inside ultra-sensitive laboratories continue searching for faint interactions. Powerful particle accelerators explore whether dark matter might reveal itself during high-energy collisions. Astronomers scan the skies for indirect signatures. So far, nothing conclusive. We understand how dark matter behaves through gravity. We still do not know what it truly is. It shapes galaxies while refusing to introduce itself. There is something wonderfully humbling about that idea. Human civilization has measured the age of the universe, photographed black holes, detected gravitational waves from colliding neutron stars, sent spacecraft beyond the edge of the solar system, and yet the invisible substance making up much of the cosmos remains unidentified. The universe continues reminding us that knowledge is never complete. Every answer opens another doorway. Every discovery uncovers another mystery. Perhaps that is why the night sky becomes even more beautiful once we realize how much of it cannot be seen. Every glowing galaxy floating above us is only the visible crest of an invisible mountain. Every cluster hangs within a sea of unseen gravity. Every star owes its existence in part to structures that have never emitted a single photon. The greatest architect in the universe works in complete silence, never asking to be noticed, never appearing in photographs, simply holding everything together, patiently, faithfully, for nearly 14 billion years. As our journey continues, the universe begins to feel less like a random collection of scattered lights and more like an intricately woven masterpiece. The galaxies no longer drift alone. They occupy places chosen long ago by an invisible framework stretching across unimaginable distances. A hidden architecture, a silent design, a structure that cannot be seen, yet reveals itself through everything it supports. Perhaps that is one of the deepest lessons the cosmos offers. Not everything important announces itself with light. Sometimes the greatest forces work quietly, invisible, patient, almost forgotten. Yet without them, nothing else could ever have found its place. If these quiet journeys through the universe help you unwind before sleep, consider subscribing so we can continue exploring its hidden wonders together. 4. The galaxies that slipped beyond reach. Imagine standing on a quiet shoreline at sunset. Far out across the ocean, hundreds of ships are slowly sailing away. At first, they remain easy to see. Their sails catch the fading light. Their shapes are clear against the horizon. But as time passes, the distance grows. One by one, the ships become smaller, fainter. Eventually, they disappear beyond the curve of the sea. Not because they sank, not because they were destroyed. They simply traveled too far away to ever be seen again. Now imagine replacing those ships with entire galaxies, each one containing hundreds of billions of stars, countless planets, perhaps civilizations, perhaps histories more ancient than our own. Right now, at this very moment, thousands upon thousands of galaxies are quietly vanishing from our future. Not because they are dying, not because their stars have gone dark, but because the universe itself is expanding so relentlessly that their light will never again be able to bridge the growing distance between us. Every second, the observable universe quietly becomes a little smaller, not in size, but in possibility. There are galaxies we can still see tonight that no future civilization will ever have the chance to discover. The cosmos is slowly closing its own windows. Tonight, we travel to one of the saddest and most beautiful realities in modern astronomy. A universe where distance is not merely measured in light years, but in opportunities that quietly disappear forever. When Edwin Hubble first realized that distant galaxies were moving away from us, the discovery transformed humanity's understanding of the cosmos. For thousands of years, people imagined the universe as something largely unchanging. The stars appeared fixed. The heavens seemed eternal. Then came an astonishing revelation. The universe was expanding, not because galaxies were exploding outward from a central point, like fragments from a firework, but because space itself was stretching. Imagine drawing small dots across the surface of a balloon. As the balloon inflates, every dot moves farther away from every other dot. None of the dots are actively traveling across the rubber. Instead, the surface beneath them expands. The universe behaves in much the same way. Galaxies are carried apart by the growth of space itself. At first glance, this expansion seems almost gentle. Nearby galaxies drift away relatively slowly. Gravity can still overcome the expansion on local scales. Our neighboring galaxy, Andromeda, is actually moving toward the Milky Way. In roughly 4 to 5 billion years, the two galaxies are expected to merge into one enormous system. The expansion of the universe is simply too weak to separate objects already tightly bound by gravity. Families remain together. Solar systems remain together. Galaxies themselves remain intact. Expansion dominates only across truly immense distances, and it is there that the story becomes extraordinary. The farther away a galaxy lies, the faster it appears to recede. This relationship, known as Hubble's law, is one of the fundamental discoveries of modern cosmology. At modest distances, the effect is easy to imagine. A galaxy 10 million light-years away drifts outward at one speed. Another, 100 million light-years away, recedes much faster, move outward still farther. The recession becomes astonishing. Eventually, something surprising happens. The expansion becomes so great that distant galaxies appear to recede faster than the speed of light. At first, this seems impossible. Has Einstein's theory been violated? Remarkably, no. Nothing is actually traveling through space faster than light. Instead, space itself continues expanding between us and those distant galaxies. Einstein's speed limit applies to motion through space. It does not prevent space itself from stretching. The distinction is subtle, yet it changes everything. To understand why, imagine walking along an airport moving walkway. Suppose you walk forward at 5 kilometers per hour. If the walkway moves backward at 2 kilometers per hour, you still make progress. Now imagine the walkway moving backward at 10 kilometers per hour. No matter how steadily you walk, you are carried away from your destination. You are not walking more slowly. The ground itself is moving beneath you. Light faces a similar challenge. Photons always travel through space at the speed of light. But if enough new space continuously forms between two distant points, the gap can still increase faster than the photons reduce it. The light keeps moving, yet the destination retreats even faster. The journey can never be completed. This creates one of the strangest boundaries in the universe. Astronomers call it the cosmic event horizon. Unlike the event horizon surrounding a black hole, this one has nothing to do with gravity trapping light. Instead, it marks the distance beyond which events occurring today can never influence us. Light emitted from galaxies beyond this horizon will simply never arrive, not tomorrow. Not in a trillion years. Not even after unimaginable stretches of cosmic time. Those galaxies are not hidden. They are permanently unreachable. Curiously, we can still observe many of these distant galaxies today. How can that be? Because the light reaching us now left them billions of years ago, when they were much closer. We are receiving ancient messages, old photographs, historical records. Meanwhile, those galaxies have continued moving farther away. If they send new light toward us today, that fresh signal will never arrive. It becomes trapped by the ever-growing expansion of space. In effect, we are witnessing their past while losing access to their future. It is a little like receiving letters from an old friend who has already sailed beyond every possible horizon. The letters continue arriving for years, yet no reply can ever catch them again. This means the observable universe is not a permanent collection of objects. It changes, not because galaxies disappear, but because the expanding universe quietly removes them from view. Imagine living hundreds of billions, or even trillions, of years from now. The night sky would appear profoundly different. Most galaxies currently visible through our telescopes would have vanished beyond the cosmic horizon. The magnificent tapestry of distant galaxy clusters would be gone. Only the merged descendants of the Milky Way and Andromeda, sometimes called Milkomeda, might remain visible nearby. Future astronomers could look into the darkness and conclude that their lonely galaxy represented the entire universe. Without the evidence available today, rediscovering cosmic expansion might become nearly impossible. Ironically, we may be living during one of the very few eras in cosmic history when the true large-scale universe is still visible. This realization gives the present moment extraordinary significance. Humanity exists during a remarkable window. The cosmic microwave background still surrounds us, carrying whispers from the beginning of time. Distant galaxies remain visible, revealing how the universe evolved across billions of years. Dark matter leaves its fingerprints through gravitational lensing. The large-scale cosmic web can still be mapped. We often think of ourselves as arriving late in the history of the universe. In one sense, that is true. Yet in another, we arrived just in time. The cosmos has not yet hidden all of its greatest clues. Why does the expansion continue accelerating? For much of the 20th century, astronomers expected gravity to slow the universe's growth. Matter attracts matter. Surely expansion should gradually weaken. Instead, observations of distant exploding stars in the late 1990s revealed something astonishing. Expansion is speeding up. Some unknown influence is pushing galaxies apart ever faster. Scientists call this mysterious phenomenon dark energy. Like dark matter, its true nature remains uncertain. It appears to fill space itself, quietly influencing the largest structures in existence. Roughly 70% of the universe's total energy content may belong to this invisible component. Once again, the cosmos reminds us that its greatest actors often remain unseen. There is something unexpectedly emotional about this picture. Every galaxy contains countless suns. Around many of those suns may orbit worlds. On some of those worlds, perhaps oceans shimmer beneath unfamiliar skies. Perhaps life emerged. Perhaps intelligent beings built observatories and wondered about distant galaxies, just as we do. And yet, with every passing moment, more of those distant realms slip forever beyond the possibility of contact. Not because anyone chose separation, not because catastrophe struck, but because the fabric of the universe quietly continued stretching. Distance became destiny. Earlier tonight, we explored the invisible architecture holding galaxies together. Now we witness another invisible force slowly carrying them apart. Creation and separation exist side by side. Gravity patiently gathers, expansion patiently releases. The universe spends billions of years weaving magnificent structures, then even more billions gently pulling them away from one another. There is no violence, no dramatic farewell, only an endless widening of silence. Perhaps that is one of the most profound lessons the cosmos offers. Not every loss happens suddenly. Some disappearances are so gradual that they escape notice entirely. The galaxies do not blink out. They slowly fade into unreachable distance. The universe does not close its doors. It quietly moves them farther away. And somewhere tonight, beyond the reach of every future telescope, ancient galaxies continue shining exactly as they always have. Their stars still rise, their planets still orbit, their histories continue unfolding. Only the expanding universe has quietly ensured that their newest light will never reach us, still traveling, still shining, forever beyond reach. 5. The cosmic signals nobody can explain. The universe is never truly silent. Even in the deepest darkness between galaxies, invisible waves are constantly crossing space. radio signals, X-rays, gamma rays, ripples of gravity, ancient light from the beginning of time. Every second, Earth is bathed in messages arriving from every direction. Most of them make perfect sense. Astronomers know which stars produce them, which galaxies emit them, which exploding supernovae create their distinctive patterns. The universe usually follows its own quiet logic. But every so often, something happens that no one expects. A burst of radio energy appears from nowhere. It lasts only a fraction of a second. Then it vanishes, never repeating in quite the same way again. Sometimes a telescope captures a signal unlike anything ever recorded before. Scientists search desperately for an explanation. They examine the equipment. They check for human interference. They compare observations from observatories around the world. And still, the answer refuses to appear. Perhaps the most famous of all arrived on a warm summer night in 1977. It lasted only 72 seconds. One astronomer looked at the printed data, circled the numbers in red ink, and wrote a single word beside them. Wow! Nearly 50 years later, no one knows exactly what produced it. Tonight, we follow the universe's strangest whispers, signals that appeared without warning, disappeared without farewell, and left humanity listening to a silence that still has not been fully explained. The universe communicates in ways our senses cannot naturally perceive. Human eyes detect only a tiny slice of the electromagnetic spectrum. Visible light represents less than a narrow window within an enormous cosmic language. Beyond red lies infrared, then microwaves, radio waves. Beyond violet lie ultraviolet rays, X-rays, gamma rays. Each carries information from different kinds of objects. If our eyes evolved to see radio waves instead of visible light, the night sky would look utterly unfamiliar. Invisible galaxies would suddenly blaze with enormous halos. Pulsars would flash rhythmically. The Milky Way itself would glow with intricate structures hidden from ordinary vision. Astronomy has taught us that every wavelength tells a different story. Some of those stories are beautifully understood. Others remain deeply mysterious. Perhaps the strangest modern example is the phenomenon known as fast radio bursts, often abbreviated as FRABs. The first confirmed burst was discovered only in 2007, while astronomers were examining old telescope data. At first, many suspected a mistake. The signal had lasted only a few thousandths of a second, yet during that unimaginably brief instant, it released as much energy in radio waves as our sun emits over several days. Then it disappeared. Nothing remained. No obvious source, no visible explosion, no lingering afterglow. Only a fleeting whisper crossing billions of light years before reaching Earth. Initially, scientists wondered whether the burst had originated much closer to home. Perhaps faulty electronics, perhaps military transmissions, perhaps an unexpected atmospheric effect. Extraordinary claims demand extraordinary evidence. Fortunately, more bursts appeared, then more. Eventually, astronomers realized these events were arriving from galaxies far beyond the Milky Way. They were genuine cosmic phenomena. Whatever created them possessed astonishing power. Yet because each burst lasted only milliseconds, locating its origin proved incredibly difficult. Imagine hearing a single raindrop strike your roof in the middle of the night, then trying to determine which cloud produced it. That is roughly the challenge astronomers faced. Today, hundreds of fast radio bursts have been detected. Some occur only once. Others repeat unpredictably. One source may remain silent for months before suddenly producing dozens of bursts. Another may never speak again. This diversity has made the mystery even more fascinating. Several promising explanations exist. Some FRBs may originate from magnetars, young neutron stars possessing magnetic fields trillions of times stronger than Earth's. These extraordinary objects occasionally release violent magnetic eruptions capable of producing intense radio flashes. Observations have confirmed that at least one magnetar within our own galaxy generated an FRB-like event. It was a major breakthrough. Yet not every fast radio burst fits this explanation perfectly. Some are brighter, some behave differently. Others repeat with puzzling patterns that remain difficult to explain. The universe seems to be telling more than one story at once. Long before fast radio bursts became famous, another signal had already earned legendary status. On August 15, 1977, the Big Ear Radio Observatory at Ohio State University was quietly scanning the sky as part of the search for extraterrestrial intelligence. Unlike many science fiction stories, SETI does not listen for spoken language. Instead, it searches for narrow-band radio signals unlikely to arise naturally. Artificial transmitters often produce concentrated frequencies. Nature usually creates broader, messier spectra. That evening, the telescope detected something extraordinary. A remarkably strong signal appeared near the frequency associated with hydrogen, the most abundant element in the universe and a logical choice for interstellar communication. The signal matched exactly what astronomers expected from a distant source drifting through the telescope's field of view. It remained detectable for 72 seconds. Then it vanished. Astronomer Jerry Amon examined the computer printout days later. Surprised by the signal's unusual strength, he circled the sequence 6EQUJ5 and wrote one spontaneous remark in the margin. Wow. The name remained forever. The WOW signal. What produced it? Nearly half a century later, no one knows. Astronomers have repeatedly searched the same region of sky. The signal has never returned. Some researchers proposed reflections from Earth-based transmissions. Others suggested passing comets surrounded by hydrogen clouds, though that explanation remains debated and has not achieved broad acceptance. Natural astrophysical events have also been considered. None explains every aspect completely. The mystery endures not because scientists lack ideas, but because the evidence consists of a single fleeting observation. The universe whispered once, then became silent. There have been other curious moments. In 1967, graduate student Jocelyn Bell Burnell noticed remarkably regular radio pulses arriving every 1.337 seconds. The signal was so precise that, jokingly, members of the research team temporarily labeled the source LGM1, Little Green Men 1. The nickname reflected humor rather than belief. Even so, the regularity was astonishing. Soon afterward, additional similar sources were discovered elsewhere in the sky. The extraterrestrial hypothesis quickly faded. Instead, astronomers had uncovered one of the universe's most extraordinary objects, pulsars. Rapidly spinning neutron stars sweeping narrow beams of radiation across space like enormous cosmic lighthouses. What first appeared almost artificial became an entirely new chapter in astrophysics. The lesson was profound. Sometimes the strangest signals reveal not intelligent civilizations, but entirely new kinds of nature. Even today, mysterious radio emissions continue surprising astronomers. Some originate from planets interacting with powerful magnetic fields. Others come from black holes consuming nearby matter. Still others emerge from regions where enormous clouds of gas collapse into newborn stars. Every improvement in telescope sensitivity uncovers phenomena no one expected to find. The more carefully humanity listens, the more complicated the cosmic conversation becomes. It is as though the universe possesses countless voices, each speaking a different dialect across the electromagnetic spectrum. Perhaps the most remarkable aspect of these mysteries is not that they remain unsolved. It is that we are capable of hearing them at all. Radio waves travel across unimaginable distances. A signal leaving a distant galaxy may spend billions of years crossing expanding space before gently passing through Earth's atmosphere. At precisely that moment, an array of antennas detects a tiny fluctuation in electrical current. A faint whisper becomes data. Data becomes curiosity. Curiosity becomes discovery. Sometimes, it becomes another mystery. Earlier tonight, we explored the oldest light ever observed, carrying memories from the universe's infancy. We traced the invisible architecture guiding galaxies across cosmic scales. Now, we encounter something different. Not ancient photographs, not silent structures, but fleeting voices, short-lived messages whose meanings remain uncertain. Some already have promising explanations. Others continue resisting every attempt at understanding. Science has never claimed to possess all the answers. Its greatest strength has always been its willingness to admit uncertainty while continuing to listen. Perhaps that is the true beauty of the night sky. It is not a finished book. It is an ongoing conversation. Every telescope adds another sentence. Every discovery teaches us a new word. Every unexplained signal reminds us that the universe still has stories left untold. Some whispers become galaxies. Some become pulsars. Some become entirely new branches of physics. And perhaps a few remain exactly what they are. Brief echoes crossing billions of years, appearing only once, inviting generations of curious minds to keep listening. Because somewhere tonight, while the Earth quietly turns beneath the stars, another mysterious signal may already be racing toward us, crossing the darkness, patiently carrying its secret, waiting for someone somewhere to hear the universe whisper. One more time, 6. The worlds that should never have existed. For centuries, humanity believed planets followed simple rules. Small rocky worlds orbited close to their stars. Giant gas planets formed much farther away, where temperatures were cold enough for ice and enormous atmospheres to develop. It was neat, orderly, predictable. The solar system seemed to provide the perfect blueprint for how every planetary system in the universe should work. Then astronomers began discovering planets around other stars. And suddenly, the blueprint fell apart. They found giant worlds hugging their stars so closely that a single year lasted only a few Earth days. Planets darker than coal, worlds where iron rains from the sky, others with temperatures hotter than many stars. Planets drifting alone through interstellar darkness with no sun at all. At first, many scientists suspected something had gone wrong. Perhaps the telescopes had made a mistake. Perhaps the data contained hidden errors, because according to everything astronomers thought they understood, these worlds simply shouldn't exist. And yet, one by one, the impossible planets kept appearing. Each discovery quietly whispered the same uncomfortable truth. The universe had never promised to follow the examples we found at home. Our solar system was not the rule. It was only one story among billions. Tonight, we leave behind the familiar planets we have known since childhood. Instead, we journey toward worlds so extraordinary that even the astronomers who discovered them struggled to believe what they were seeing. For thousands of years, the only planetary system humanity could study was our own. Mercury raced close to the Sun. Venus glowed beneath thick clouds. Earth occupied the comfortable region where liquid water could exist. Mars marked the beginning of colder territory. Beyond it came the enormous gas giants: Jupiter, Saturn, Uranus, Neptune. The arrangement seemed logical. Close to the Sun, only heavy rocky materials could survive the intense heat. Farther away, where temperatures dropped dramatically, gases and frozen compounds accumulated into giant planets. Astronomers naturally assumed this was how nature built planetary systems everywhere. It was an elegant theory, one supported by every example available, until humanity finally acquired the technology to search beyond our own neighborhood. The first confirmed planet orbiting a Sun-like star was announced in 1995. Its name was 51 Pegasi b. Instead of resembling Jupiter, as scientists expected the easiest discoveries to do, it completely overturned existing theories. It possessed roughly half the mass of Jupiter, yet it orbited astonishingly close to its star. One complete orbit required only about 4 days. Imagine placing Jupiter far closer to the Sun than Mercury. Temperatures soared above 1,000 degrees Celsius. Its atmosphere expanded under relentless stellar heat. Nothing remotely similar existed in our own solar system. Many astronomers were genuinely shocked. How could a giant planet possibly form there? According to prevailing theories, it couldn't. Eventually, scientists realized the planet had probably not formed near its star at all. Instead, it likely originated much farther away, before gradually migrating inward through interactions with the disk of gas and dust surrounding the young star. Planetary systems, it turned out, were not static. They evolved. Planets wandered. Some moved inward. Others were thrown outward. Entire systems rearranged themselves over millions of years. The neat architecture of our solar system suddenly appeared only one possible outcome among countless others. Nature possessed far greater imagination than anyone had anticipated. As more planets were discovered, the surprises only multiplied. Astronomers identified enormous worlds orbiting 2 stars simultaneously, much like the fictional planet Tatooine from Star Wars. Others orbited stars that had already died, continuing their lonely journeys around stellar remnants called white dwarfs. Some planetary systems contained giant worlds following wildly elongated paths, swinging close to their stars before disappearing into deep space for years or even centuries. The universe seemed almost determined to challenge every assumption humans had developed from observing our own celestial neighborhood. Then came the rogue planets. Earlier in our journey, we briefly visited worlds wandering between the stars. These are planets that no longer orbit any sun. Some may have been violently ejected from their original systems after gravitational encounters with giant neighboring planets. Others may have formed almost independently from collapsing clouds of gas. Without sunlight, they drift through interstellar darkness. No sunrise, no sunset, only endless night. For many years, astronomers questioned whether such lonely worlds could truly exist in significant numbers. Today, evidence suggests there may be billions of rogue planets wandering through the Milky Way alone. Perhaps even more numerous than the stars themselves, entire worlds traveling forever without a home. Some planets are astonishingly hot. The class known as ultra-hot Jupiters orbit so close to their stars that their atmospheres reach temperatures exceeding 2,000 degrees Celsius. At these extremes, molecules break apart, metals can vaporize, powerful winds race around the planet at several kilometers per second, redistributing heat between permanent day and night sides. On some of these worlds, clouds may consist not of water, but of vaporized rock or metal compounds. The familiar weather patterns of Earth become completely meaningless. Nature invents entirely new climates. One particularly fascinating example is WASP 76b. Observations suggest that iron may exist as vapor on its intensely heated day side. Powerful atmospheric circulation transports this vapor toward the cooler night side, where temperatures are lower. There, the iron may condense into droplets before falling through the atmosphere. Popular descriptions often summarize this as iron rain. The exact details of the atmospheric processes are still being actively studied, but the underlying idea is astonishing enough. On Earth, clouds bring gentle rain. On another world, the clouds may carry molten metal. Not every impossible planet is hot. Some challenge expectations in entirely different ways. astronomers have discovered super-Earths, rocky planets several times more massive than our own. Curiously, our solar system contains nothing quite like them. Elsewhere, however, they appear remarkably common. Some may possess global oceans hundreds of kilometers deep. Others could have crushing atmospheres, unlike anything found on Earth. Still others may consist largely of exotic mixtures of rock, ice, and compressed minerals created under enormous pressure. Once again, our planetary family proves not to be typical. Then there are the planets that seem almost impossibly dark. One famous example, TRES 2b, reflects very little of the light striking its atmosphere. It is darker than charcoal, darker than fresh asphalt. Scientists believe its intense heat prevents the formation of bright reflective clouds, while atmospheric chemistry absorbs much of the incoming light. Were it not for its faint reddish glow caused by extreme temperatures, it might appear almost invisible against the blackness of space, a planet that nearly disappears into the darkness surrounding it. Perhaps the most remarkable lesson emerging from the past 3 decades of exoplanet discoveries is not that strange planets exist. It is that they exist in overwhelming abundance. Astronomers have now confirmed thousands of exoplanets. Each year brings hundreds more. Some resemble Earth, many do not. Some orbit tiny red dwarfs. Others circle giant stars. Some exist inside compact systems containing numerous tightly packed planets. Others travel almost alone. Every discovery expands our understanding, while simultaneously reminding us how little of the universe we have explored. The Milky Way alone likely contains hundreds of billions of planets. Humanity has studied only a tiny fraction. Earlier tonight, we listened to mysterious radio whispers crossing billions of light years. Before that, we followed galaxies slowly slipping beyond the observable universe. Now, we arrive somewhere far more intimate, entire worlds, places that, despite their astonishing diversity, still obey the same fundamental laws of physics that shape our own planet. Gravity gathers matter, stars ignite, planets form. Yet from those familiar ingredients, nature creates astonishing variety. It is rather like music. Only a handful of notes exist, yet countless melodies emerge. The universe appears to compose planetary systems in much the same way. Perhaps that is why exoplanets inspire such quiet wonder. Every new discovery reminds us that Earth is neither the center of creation nor the standard by which every other world should be judged. Instead, it is one beautiful expression among an endless collection of possibilities. Some worlds glow beneath twin suns. Some wander eternal darkness. Some endure storms of vaporized rock. Some may hide oceans beneath frozen crusts. And somewhere, perhaps even now, astronomers are examining data from another distant star. A tiny wobble, a slight dimming of light, another impossible planet waiting patiently to overturn everything we thought we understood. Because the universe has never been interested in meeting our expectations, its greatest talent has always been quietly exceeding them. One extraordinary world at a time. 7. The civilizations we may never meet. Look up at the night sky for a moment. On a clear evening, you might see a few thousand stars. Beautiful, peaceful, almost comforting. But what you are seeing is only the tiniest fraction of what truly exists. Our Milky Way alone contains hundreds of billions of stars. Beyond it lie hundreds of billions of other galaxies. Together, they contain more worlds than there are grains of sand on every beach on Earth. Some of those worlds almost certainly formed billions of years before our own. Some orbit stars far older than the Sun. If life emerged here through ordinary chemistry, why wouldn't it emerge elsewhere? And if intelligence is not unique, then why does the universe remain so astonishingly quiet? For more than a century, humanity has been listening. Powerful radio telescopes have searched the heavens. Scientists have scanned millions of stars. Spacecraft have carried messages beyond the solar system. Yet no unmistakable reply has ever arrived. No greeting, no warning, no invitation, only silence. It is one of the greatest mysteries ever contemplated. A mystery so profound that it has become known as the Fermi paradox. Because if the universe is overflowing with opportunities for life, why does it feel so empty? Tonight, we wander into that extraordinary silence, not searching for monsters, not searching for invaders, but searching for something perhaps even more mysterious. The reason why an ancient universe filled with countless worlds has never introduced itself. The question itself is surprisingly simple. In 1950, physicist Enrico Fermi was enjoying lunch with colleagues when the conversation turned toward extraterrestrial life. After listening for a while, Fermi reportedly asked one remarkably straightforward question: "Where is everybody?" That single sentence has echoed through astronomy ever since. Because the numbers appear overwhelmingly persuasive. The Milky Way contains perhaps 100 to 400 billion stars. Many possess planets. Modern discoveries suggest that planetary systems are not unusual at all. Earlier tonight, we visited worlds stranger than anyone imagined possible. Some resemble Earth in size, others orbit within regions where liquid water could potentially exist. With so many opportunities, the emergence of life somewhere else seems entirely plausible. And given enough time, perhaps intelligence as well. The universe has also had plenty of time to work with. Earth formed about 4.5 billion years ago. Yet many stars in our galaxy are billions of years older than the Sun. Imagine a civilization beginning its scientific journey 1 billion years before humanity. Now, imagine another beginning 5 billion years earlier. The difference is almost impossible to comprehend. Human civilization has used radio technology for little more than a century. 5 billion years is 50 million times longer. Compared with cosmic history, humanity has only just learned to whisper. Some scientists have asked an intriguing question. If even one technological civilization developed interstellar travel, even at relatively modest speeds, it could gradually spread across the galaxy. Not in thousands of years, not even millions, but perhaps over tens or hundreds of millions of years. That sounds unimaginably long to us. Yet compared with the Milky Way's age of more than 13 billion years, it is surprisingly brief. A sufficiently patient civilization could, in theory, explore enormous portions of the galaxy long before humanity evolved. If that possibility exists, why don't we see evidence of it? Perhaps the simplest answer is also the most humbling. Maybe intelligent life is extraordinarily rare. Life itself may emerge easily. Single-celled organisms appeared on Earth relatively early, but complex multicellular life required billions of years. Intelligence capable of building telescopes took even longer. Perhaps countless planets are covered with oceans filled only with microscopic organisms. Perhaps forests grow beneath alien skies without ever producing civilizations. Perhaps intelligence is not the inevitable destination of evolution, only one possible path among many. Another possibility is even quieter. Maybe civilizations rarely survive for very long. Technology brings extraordinary power. It also introduces extraordinary risks: environmental collapse, nuclear war, artificial intelligence, biotechnology, resource exhaustion. These are not predictions, only possibilities. Perhaps many civilizations eventually encounter challenges they cannot overcome. Their stars continue shining, their planets continue orbiting, yet the voices disappear. The galaxy slowly fills with silent ruins rather than thriving societies. Astronomers sometimes refer to this idea as passing through a great filter, a difficult stage that very few civilizations successfully survive. Whether that filter lies behind us or ahead of us remains entirely unknown. There is another thought that feels strangely comforting. Perhaps advanced civilizations simply have no desire to announce themselves. When humanity first developed radio transmitters, we unintentionally leaked signals into space. Television broadcasts, radar pulses, military communications. These radio waves continue expanding outward at the speed of light. Yet, after only about 100 years, our detectable bubble extends merely 100 light years. That sounds enormous. It is not. Compared with the Milky Way, it is a tiny circle surrounding the Sun. Most of our galaxy has absolutely no idea we exist. Likewise, another civilization could easily remain undetected simply because its signals have not yet reached us, or ours have not yet reached them. The galaxy is astonishingly large. Distance alone creates silence. Perhaps communication itself is the problem. Imagine trying to speak with a whale using mathematics scratched into the sand, or explaining music to someone who has never experienced sound. Even among intelligent species on Earth, communication can be remarkably limited. Now imagine two civilizations separated not only by light years, but by millions of years of independent evolution. Their biology, their senses, their languages, even their concept of intelligence might differ completely from ours. Perhaps they communicate using neutrinos, or quantum phenomena, or methods humanity has not yet discovered. We continue listening for radio waves because that is the technology we understand. The universe may be speaking an entirely different language. Some astronomers wonder whether the evidence is already surrounding us, simply too subtle for us to recognize. Earlier tonight, we explored mysterious radio bursts crossing billions of light years. Current evidence strongly favors natural astrophysical explanations for these events. Magnetars, extreme magnetic fields, exotic stellar remnants. Science has become increasingly successful at explaining phenomena once considered mysterious. Again and again, nature proves more creative than speculation. And yet, the possibility remains that entirely new natural phenomena, and perhaps entirely unexpected forms of technology, still await discovery. The universe has surprised us many times before. There is little reason to believe it has finished doing so. Then there is perhaps the gentlest possibility of all. Maybe the galaxy is simply asleep. Imagine standing alone inside an enormous forest during winter. No birds sing, no insects buzz. The silence feels complete, yet life has not disappeared. It waits. Spring eventually arrives. Perhaps intelligent civilizations are similarly scattered across cosmic history, rather than existing simultaneously. One civilization rises. Millions of years later, another begins. Their lifetimes never overlap. Like ships crossing the same ocean centuries apart, they unknowingly miss one another. The universe may be full of stories that never meet. There is something deeply moving about that thought. Earlier tonight, we followed galaxies slipping beyond the observable horizon. Now we discover that civilizations may also pass beyond one another's reach, not through expansion alone, but through time itself. One species gazes upward. Long after it vanishes, another begins asking the very same questions beneath another distant sky. Neither ever knows the other existed. The silence between them is not empty. It is simply too vast. Despite decades of searching, humanity has not found convincing evidence of extraterrestrial intelligence. Some people find this disappointing. Perhaps it should inspire the opposite feeling, because every unanswered question keeps the universe wonderfully alive. Every quiet night sky remains filled with possibility. Every newly discovered planet could become the setting for a story we have not yet imagined. Perhaps somewhere beneath the crimson light of an ancient red dwarf, another civilization is also wondering whether it is alone. Perhaps they are listening. Perhaps they are searching. Perhaps they have looked toward our tiny yellow star and seen nothing more than an ordinary point of light, among hundreds of billions of others, just as we have. Whether the universe is crowded or quiet, one truth remains unchanged. The search itself has already transformed us. In asking whether we are alone, humanity learned how stars are born, how planets form, how galaxies evolve, how chemistry gives rise to life. Sometimes the greatest discoveries are not the answers we expected. They are the questions that taught us how to look. Perhaps one day the silence will end. Perhaps it never will. Until then, the stars continue shining with quiet patience. And somewhere beyond the reach of every telescope we have built, another world may be looking into its own night sky, wondering exactly the same thing. If you're enjoying these peaceful mysteries from across the cosmos, subscribing helps us continue discovering one impossible question at a time. 8. The objects that vanished before our eyes. Imagine devoting your entire career to studying a distant world. Night after night, your telescope returns the same familiar signal, a tiny dip in starlight, a predictable orbit. A planet faithfully circling its distant sun. Years pass. The measurements become increasingly precise. The world seems as permanent as the stars themselves. Then, something unexpected begins to happen. The planet arrives a little earlier than predicted. Its shadow grows strangely uneven. Each orbit looks slightly different from the last. The changes are almost too subtle to notice. At first, you assume your instruments need calibration. Perhaps the atmosphere blurred the observations. Perhaps a software error slipped unnoticed into the calculations. But the pattern continues, month after month, year after year. The once familiar world grows fainter. Its outline becomes less distinct. Eventually, the signal disappears altogether. Not because your telescope failed, not because the star exploded, but because the planet itself is no longer there. Somewhere in the vast darkness of the universe, entire worlds are slowly being destroyed. Stars consume their own planets. Black holes tear apart wandering suns. Asteroids collide with enough violence to erase ancient landscapes. Even galaxies can gradually dismantle one another over billions of years. The universe often appears timeless, calm, unchanging. Yet beneath that peaceful surface, destruction quietly accompanies creation. Tonight, we follow the disappearing objects of the cosmos, not the dramatic explosions that briefly illuminate the heavens, but the slow, patient vanishings that unfold so gradually that they almost escape our notice. One of the most fascinating examples involves a distant object known as KIC 125575448 When astronomers first examined data from NASA's Kepler Space Telescope, they noticed something deeply unusual. Most planets crossing in front of their stars produce remarkably consistent shadows. Each transit blocks nearly the same amount of light. The pattern repeats with extraordinary precision. This object behaved differently. Sometimes it blocked much more starlight, sometimes much less. Its silhouette constantly changed. It was as though the planet itself refused to maintain a stable shape. At first, researchers considered the possibility of measurement errors. Yet, the strange behavior persisted. Eventually, a remarkable explanation emerged. The planet appeared to be slowly evaporating. Unlike Earth, this unfortunate world orbits astonishingly close to its parent star. Temperatures rise to nearly 2,000 degrees Celsius. Its rocky surface is heated so intensely that minerals begin vaporizing. Imagine mountains slowly turning into gas. Streams of vapor escape into space, carrying tiny dust particles behind them. These particles form an enormous tail stretching millions of kilometers, rather like the glowing tail of a comet. With every orbit, the planet loses a little more of itself. Rock becomes dust. Dust becomes space. Over immense stretches of time, an entire world gradually dissolves into nothing. Astronomers may actually be witnessing a planet disappearing before their eyes. Remarkably, this process is not unique. Several other disintegrating exoplanets have now been identified. Each tells a similar story. Extreme heat strips material from their surfaces. Powerful stellar radiation drives matter outward. The planets shrink, slowly, patiently. Their endings do not arrive with spectacular explosions. Instead, they fade grain by grain into the darkness surrounding their stars. The universe possesses many ways to erase worlds. Some are astonishingly gentle. Stars themselves experience similar endings. Earlier tonight, we explored planets orbiting dead suns. Now imagine the reverse. As stars like our own sun exhaust their hydrogen fuel, they begin swelling into enormous red giants. Their outer layers expand dramatically. Mercury will almost certainly disappear. Venus is expected to follow. Earth's ultimate fate remains uncertain, but current models suggest our planet will likely become uninhabitable long before the sun reaches its greatest size, and it may eventually be engulfed as the sun expands. To an outside observer, the solar system would gradually lose its inner worlds, not through collision, not through violence, simply because their aging star quietly grew larger. The planets would vanish into the expanding stellar atmosphere, becoming part of the star itself. Sometimes disappearance occurs through gravity rather than heat. Near the center of almost every large galaxy lurks a supermassive black hole. Most remain surprisingly quiet. Yet occasionally, an unlucky star wanders too close. The difference in gravity between the side nearest the black hole and the side farther away becomes overwhelming. The star stretches, longer, thinner, until it is pulled apart completely. Astronomers call these dramatic episodes tidal disruption events. For a brief period, the shredded stellar material forms a brilliant disk spiraling into the black hole. Then, as the remaining gas disappears beyond the event horizon, even that brilliant flare fades. Another star quietly leaves the universe of visible objects forever. Not every disappearance involves destruction. Sometimes, the universe simply hides things from view. Earlier in our journey, we followed galaxies slipping beyond the observable horizon as cosmic expansion carried them away. Here, on much smaller scales, dust performs a similar trick. Enormous clouds of interstellar dust drift between stars. Visible light cannot easily penetrate them. Entire stellar nurseries remain concealed behind these dark curtains. For centuries, astronomers believed certain regions of the Milky Way contained almost no stars. Modern infrared telescopes revealed the truth. The stars had never vanished. They had merely been hidden. The universe often reminds us that disappearance and invisibility are not always the same thing. Even galaxies themselves slowly change beyond recognition. When two galaxies pass near one another, gravity gently distorts their elegant spiral arms. Stars are rarely involved in direct collisions because the distances between them are enormous. Instead, the galaxies gradually reshape each other. Long tidal streams stretch outward. Gas clouds collide. New stars ignite. Over billions of years, the original spiral structures dissolve. Eventually, a single giant elliptical galaxy emerges. The original galaxies have not truly disappeared. Yet, their familiar identities have faded into something entirely new. Creation and loss become impossible to separate. There are even stars that seem to vanish unexpectedly. Astronomers occasionally discover massive stars visible in older observations, but strangely absent from newer ones. In a few cases, researchers have suggested that certain stars may collapse directly into black holes with little or no bright supernova explosion. These events remain an active area of research, and not every candidate has been confirmed. If such failed supernovae occur, a brilliant star could simply fade away. leaving behind an invisible black hole where light once shone. Imagine looking toward a familiar constellation one night and realizing one of its brightest stars had quietly gone out. No dramatic farewell, only absence. Human beings often think of permanence as a defining feature of the heavens. Ancient civilizations named the fixed stars. Generations grew beneath seemingly unchanging skies. Yet modern astronomy paints a gentler picture. Nothing lasts forever. Mountains erode, planets evaporate, stars exhaust their fuel, galaxies merge. Even the observable universe slowly changes as expansion carries distant light beyond our reach. The cosmos is not a museum frozen in time. It is a living story. Every chapter quietly replaces the one before it. Earlier tonight, we wondered whether intelligent civilizations might rise and vanish without ever meeting one another. Now we witness the same pattern written into the physical universe itself. Worlds appear, worlds disappear, not because the universe is cruel, but because change is woven into its deepest fabric. Every ending quietly prepares the conditions for another beginning. The dust from dying stars becomes new planets. The debris from shattered worlds enriches future solar systems. Nothing is truly wasted, only transformed. Perhaps that is why these disappearing objects inspire something gentler than sadness. They remind us that the night sky is not a static painting hanging forever above our heads. It is an unfolding performance. Every observation captures only a single moment. Every telescope records one frame in an unimaginably long story. Somewhere tonight, a distant planet is shedding another cloud of mineral dust. A giant star is expanding by another few kilometers. A black hole is quietly swallowing the last fragments of an ancient sun. And somewhere else, hidden beyond the reach of our instruments, another object has already vanished forever, leaving behind only faint traces of its existence. A whisper of light, a trail of dust, a subtle change in a distant star. Small clues reminding us that even the greatest structures in the universe are not immune to time. They too come and go, slowly, silently, almost without anyone noticing, until one day, there is nothing left to see. 9. The spacecraft that defied physics. Imagine launching a spacecraft on a journey that will last decades. Every engine burn is carefully calculated. Every gravitational assist is predicted years in advance. Every tiny change in velocity is measured to astonishing precision. Physics, after all, is supposed to be reliable. Newton's laws have guided ships across oceans, sent astronauts to the moon, delivered robotic explorers to the outer planets. Space is often described as the most predictable environment imaginable. There is almost no air, almost no friction, almost nothing to disturb a spacecraft once its engines fall silent. Its path should unfold exactly as mathematics predicts. And for the most part, it does. But every now and then, something unexpected appears. A spacecraft begins drifting ever so slightly away from its calculated trajectory. The difference is almost unimaginably small. Not kilometers, not meters. Sometimes only a fraction of a millimeter each second. Tiny enough to escape notice for years, yet persistent enough that, over millions or even billions of kilometers, it becomes impossible to ignore. Engineers examine every line of computer code. Astronomers check the positions of planets. Physicists revisit equations that have described motion for centuries. Could gravity itself be behaving differently? Could some invisible force be acting across the solar system? Or had humanity stumbled upon the first crack in its understanding of the universe? For a brief moment, some of the greatest scientific minds on Earth wondered whether our spacecraft had discovered entirely new physics. Tonight, we follow those mysterious journeys, not because the universe had broken its own rules, but because even the smallest unexplained motion can lead us toward remarkable discoveries. By the time humanity began exploring the outer solar system, celestial navigation had become one of science's greatest triumphs. Spacecraft routinely traveled hundreds of millions of kilometers while arriving within astonishing distances of their intended targets. The calculations involved were extraordinarily complex. The gravity of planets, the pull of moons, the pressure of sunlight, the rotation of Earth. Even the slight bending of space-time predicted by Einstein had to be included for the highest precision. Every successful mission represented a quiet celebration of physics. Again and again, nature behaved exactly as expected, which is why the next mystery became so intriguing. In the early 1970s, NASA launched two remarkable spacecraft. Pioneer 10 and Pioneer 11 became humanity's first explorers of the outer solar system. They flew past Jupiter. Later, Pioneer 11 continued onward to Saturn. After completing their historic encounters, both spacecraft continued traveling into deep space, far beyond the giant planets, far beyond the regions where sunlight still feels warm. As the years passed, engineers continued tracking their motions using radio signals transmitted across billions of kilometers. Everything appeared routine, until someone noticed something extraordinarily subtle. The spacecraft seemed to be slowing down, not dramatically, only by an incredibly tiny amount. The effect was so small that no astronaut could ever have felt it. Yet sensitive measurements suggested both spacecraft experienced an unexplained acceleration directed roughly back toward the Sun. It became known as the Pioneer anomaly. At first, almost nobody considered it revolutionary. Small discrepancies occur in every engineering project. Perhaps tiny leaks from the propulsion system, perhaps unnoticed software assumptions, perhaps slight errors in planetary measurements. The simplest explanation usually proves correct. Yet years passed. The anomaly remained. As more researchers examined the data, excitement quietly grew. The effect appeared surprisingly consistent. Independent analyses confirmed that something unusual seemed present. Could gravity behave differently across enormous distances? Might Einstein's theory require modification? Could invisible matter inside the solar system exert a subtle pull? Perhaps entirely new particles filled interplanetary space. Speculation spread cautiously through the scientific community. No responsible physicist declared that Newton or Einstein had failed. But many agreed that the mystery deserved serious attention. History had shown that tiny discrepancies sometimes lead to enormous discoveries. The orbit of Mercury eventually helped confirm general relativity. Unexpected motions of Uranus led to the discovery of Neptune. Perhaps the Pioneer spacecraft were whispering another profound secret. The investigation became a remarkable detective story. Scientists reconstructed decades of mission history. Old magnetic tapes were recovered from archives. Engineering documents long forgotten were carefully re-examined. Every possible influence received renewed attention. Solar radiation, gravitational perturbations, fuel usage, antenna transmissions, even the heat generated by electrical equipment inside the spacecraft. Nothing seemed too insignificant. When measurements become this precise, every watt matters, every gram matters, every photon matters. Eventually, the solution emerged. It was both wonderfully ordinary and deeply elegant. The spacecraft generated heat from their onboard nuclear power sources. That heat did not radiate perfectly equally in every direction. Instead, slightly more infrared radiation escaped from certain parts of the spacecraft than others. Light carries momentum. Even invisible infrared photons exert an incredibly tiny push when they leave a surface. The imbalance acted like an almost unimaginably gentle thruster. Day after day, year after year, the accumulated effect produced exactly the mysterious acceleration astronomers had observed. The Pioneer spacecraft had not discovered new physics. They had demonstrated how exquisitely sensitive physics truly is. even waste heat, could gently reshape a journey across billions of kilometers. Rather than being disappointing, the solution became a triumph. It revealed the extraordinary precision modern science had achieved. Imagine detecting the gentle push created by the warmth of a spacecraft drifting through space billions of kilometers away. That level of accuracy would have seemed impossible only a century earlier. The mystery did not overthrow physics. It strengthened confidence in it. Sometimes the universe appears mysterious, not because its laws have failed, but because we have not yet accounted for every subtle detail. The Pioneer anomaly was not the only curious case. During several planetary flybys, other spacecraft experienced tiny, unexpected changes in speed. This phenomenon became known as the flyby anomaly. As spacecraft borrowed energy from Earth's motion to accelerate toward distant destinations, a few missions seemed to gain or lose just a little more velocity than calculations predicted. Again, the differences were incredibly small. Again, researchers proposed numerous explanations: Earth's atmosphere, rotation effects, measurement techniques, relativistic corrections. To this day, aspects of the flyby anomaly remain an active area of research, though its exact cause is still uncertain and may involve multiple contributing factors rather than entirely new physics. Science continues examining the evidence with patience rather than rushing toward extraordinary conclusions. These investigations reveal something important about how scientific discovery actually works. Popular stories often portray breakthroughs as sudden flashes of genius. Reality is usually quieter. Scientists rarely begin by assuming revolutionary explanations. Instead, they spend years attempting to prove themselves wrong. Every ordinary possibility must be exhausted before extraordinary ideas deserve serious consideration. This careful skepticism is not a weakness. It is one of science's greatest strengths. The universe earns our confidence by surviving every attempt to challenge our understanding. Spacecraft themselves have become astonishing laboratories. Earlier tonight, we explored mysterious radio signals crossing the cosmos. We visited invisible dark matter shaping galaxies. We watched planets slowly evaporating beneath relentless stellar heat. Now, humanity's own machines join that story, not merely as tools of exploration, but as participants. Every spacecraft carries clocks, thermometers, gyroscopes, radio transmitters, sensitive instruments capable of detecting subtle features of reality impossible to observe from Earth alone. Sometimes they discover entirely new worlds. Sometimes they reveal entirely new questions. Perhaps the most inspiring aspect of these journeys is their extraordinary patience. The Voyager spacecraft, launched in 1977, continue traveling through interstellar space today. Their radio signals require more than 20 hours to reach Earth. Commands sent from mission controllers travel nearly an entire day before arriving. Every conversation with these distant explorers unfolds at the speed of light, across billions of kilometers. They remind us that exploration is rarely dramatic. More often, it is a quiet conversation sustained across decades, a slow accumulation of tiny measurements, tiny corrections, tiny surprises, until one day, humanity understands the universe just a little better than before. Earlier in our journey, we wondered why mysterious signals sometimes appear without explanation. Here, we discover that mysteries can also emerge from our own creations. A spacecraft drifts by less than the width of a human hair each second. An unexpected acceleration appears. An entire community of scientists spends years searching for its cause, not because the discrepancy is large, but because nature deserves to be understood completely. The smallest unanswered question can illuminate the greatest truths. Perhaps that is the deepest lesson these spacecraft teach us. The universe does not always reveal its secrets through spectacular explosions or impossible phenomena. Sometimes its greatest mysteries begin with something almost invisible, a tiny deviation, a faint signal, a fraction of a degree, a spacecraft arriving ever so slightly where mathematics said it should not. Curiosity notices, patience investigates, evidence accumulates, and slowly the mystery transforms into understanding. The spacecraft continue onward, silent, faithful, still carrying humanity's questions into the darkness between the stars, following paths written not by magic, but by laws so wonderfully precise that even the warmth of a distant machine becomes part of the story. One tiny correction at a time. 10. The future sky without galaxies. Imagine standing beneath a perfectly clear night sky 1 trillion years from now. You step outside an observatory built by descendants of humanity, or perhaps by an entirely different civilization that inherited the Earth long after we are gone. The air is calm. The stars above appear beautiful. Constellations have changed beyond recognition, but the heavens still sparkle with familiar quietness. You lift an enormous telescope toward the darkness. You expect to find what astronomers have always found: countless galaxies stretching across the universe, spiral galaxies, elliptical galaxies, distant clusters glowing billions of light years away. Instead, there is almost nothing. No Andromeda, no Virgo cluster, no distant galaxies scattered across the heavens. Only one enormous island of stars fills the sky. Your own galaxy. As far as your greatest telescopes can see, the universe appears completely empty. If you had never known otherwise, you would naturally conclude that your galaxy was the entire cosmos. And you would be wrong. Not because your instruments had failed, not because the other galaxies had died, but because the universe itself had quietly carried them so far away that no light they emit in the future could ever reach you again. One day, the greatest evidence for the Big Bang may simply disappear. Future astronomers could inherit a universe that has erased almost every clue about its own beginning. Tonight, we travel to that unimaginably distant future, to an age when the night sky becomes smaller, lonelier, and strangely silent. Earlier in our journey, we followed galaxies slowly slipping beyond the observable horizon. That process has already begun. Every second, the expansion of the universe increases the distance between the largest cosmic structures. Nearby galaxies remain bound together by gravity, but those farther away continue drifting outward. Not because they are flying through space like rockets, but because space itself continues expanding. This distinction changes the future of astronomy forever. Today, humanity lives during an extraordinary era. When we point powerful telescopes toward the heavens, we see galaxies in every direction. Some are relatively nearby. Others appear so distant that their light began traveling toward Earth when the universe was only a fraction of its current age. Together, they form an enormous cosmic tapestry. Astronomers can measure expansion, map the large-scale structure of the universe, study how galaxies evolved across billions of years. We often assume that this view will always remain available. It will not. The universe is expanding. More importantly, the expansion is accelerating. Earlier tonight, we briefly encountered the mysterious influence known as dark energy. Although its true nature remains unknown, observations indicate that it dominates the large-scale evolution of the cosmos. As expansion accelerates, distant galaxies recede ever faster. Eventually, their newly emitted light can no longer overcome the continual stretching of space. Those photons begin their journey toward us, yet the destination retreats even faster. The messages are never delivered, not because the galaxies stopped shining, but because the universe quietly placed them forever beyond communication. Imagine watching thousands of lanterns floating down a river. The current gradually becomes stronger. The farther lanterns drift away ever more rapidly. Eventually, some cross a bend in the river. You know they still glow. You simply never see them again. The galaxies experience something similar. Their stars continue burning. Planets continue orbiting. Perhaps civilizations continue wondering about the cosmos. Yet, their future light never reaches ours. The universe does not extinguish them. It gently hides them. Over hundreds of billions of years, almost every galaxy beyond our own gravitational neighborhood disappears from view. The local group of galaxies, including the Milky Way, Andromeda, and dozens of smaller companions, remains gravitationally bound. While the rest of the universe expands away, gravity keeps these nearby galaxies together. Long before the distant cosmos vanishes, however, another transformation unfolds much closer to home. The Milky Way and Andromeda slowly approach one another. Their encounter will not resemble the violent collisions often portrayed in films. Stars are separated by enormous distances. Direct stellar collisions remain extraordinarily unlikely. Instead, gravity patiently reshapes both galaxies. Their elegant spiral arms gradually dissolve. Gas clouds collide. New generations of stars ignite. After billions of years, the two systems merge into one enormous elliptical galaxy. Astronomers sometimes call this future galaxy Milkomeda. It will become the entire visible universe for unimaginably distant descendants. Now, imagine being born inside that future galaxy. Every astronomy textbook begins with the same observations. Stars fill one enormous galaxy. Nothing else exists. No neighboring galaxies, no expanding universe, no observable cosmic web. Without external galaxies, Edwin Hubble's discovery becomes impossible. There are no receding galaxies whose redshifts reveal cosmic expansion. One of the greatest discoveries in scientific history simply cannot be repeated. Future astronomers may spend centuries trying to understand the universe while lacking one of its most important clues. The losses continue. Today, we observe the cosmic microwave background, the oldest light in existence. Earlier tonight, we followed that ancient radiation back to a time only 380,000 years after the Big Bang. But the universe keeps expanding. As it does, those microwave wavelengths continue stretching. Eventually, they become so enormously elongated that detecting them becomes extraordinarily difficult. In the unimaginably distant future, the cosmic microwave background may fade below practical observability altogether. The oldest photograph of creation quietly disappears, not because it ceased existing, because it stretched beyond reach. The universe slowly edits its own history. This creates one of the strangest ironies in all of science. Humanity often imagines that future civilizations will automatically know more than we do. In many ways, they certainly will. Their technology may exceed ours beyond imagination. Their mathematics may solve problems we cannot even formulate today. Yet regarding cosmology, they may possess less observational evidence than we do. Not because they are less intelligent, because the universe itself has hidden the data. Knowledge depends not only on curiosity, but on timing. This realization changes the way we think about our place in history. We usually describe ourselves as late arrivals. The universe is already nearly 14 billion years old. Stars have lived and died countless times. Galaxies have merged for eons. Compared with cosmic history, humanity appeared remarkably recently. Yet perhaps we arrived during one of the luckiest moments imaginable. The universe is old enough for planets, life, and intelligent observers to exist, yet still young enough to preserve evidence of its own beginnings. The cosmic microwave background remains visible. Distant galaxies still illuminate the expanding universe. The large-scale cosmic web can still be mapped. The clues have not yet disappeared. There is something deeply poetic about this. The universe behaves almost like an ancient storyteller. For billions of years, it patiently leaves clues scattered throughout space. Gradually, however, those clues fade. Old pages weather away. Ink slowly disappears. Future readers inherit only fragments. Perhaps we are among the final generations capable of reading nearly the entire story. Earlier tonight, we listened for civilizations that may never meet. We watched galaxies slip beyond the observable horizon. We followed spacecraft quietly revealing hidden truths about motion itself. Now, those themes converge. Distance, time, memory, all become inseparable. The future sky does not grow darker because stars stop shining. It grows quieter because information itself becomes inaccessible. The universe remains magnificent. It simply becomes increasingly unknowable. Perhaps this offers an unexpected lesson about the present. Every image captured by today's telescopes preserves something temporary. The deep field photographs revealing thousands of distant galaxies are not merely beautiful pictures. They are historical documents, records of a universe future observers may never witness again. Every measurement of cosmic expansion becomes part of an archive that cannot easily be recreated. Astronomy is not only discovering the universe, it is preserving memories that time itself will eventually erase. And yet, even in that unimaginably distant future, wonder will survive. Future astronomers will still study stars. They will still explore planets. They will still ask impossible questions. Perhaps they will eventually uncover subtle clues pointing toward an ancient, expanding universe long forgotten. Or perhaps they will never know. Perhaps they will believe their lonely galaxy is all that has ever existed. Standing beneath a quiet sky, surrounded by billions of stars, completely unaware that beyond the darkness lie trillions upon trillions of other galaxies, still shining, still evolving, forever hidden by the relentless expansion of space. The universe will not have become smaller, only lonelier, and somewhere, across distances no light can ever cross again, countless galaxies will continue their silent journeys, invisible, unreachable, waiting in a darkness that no telescope of the future will ever illuminate again. 11. The last messages humanity may ever send. Long after every city has crumbled into dust, long after every language spoken today has transformed into something unrecognizable, long after no living person remembers our names, human voices may still be traveling through the darkness between the stars, not as sound. Sound cannot cross the vacuum of space, but as radio waves, tiny ripples of energy expanding outward at the speed of light. Every television broadcast, every radio station, every radar pulse, every signal ever intentionally aimed toward the heavens. They never truly disappeared. They simply kept going. Right now, at this very moment, a faint shell of Earth's history, nearly 150 light-years wide, surrounds our planet. Inside that expanding bubble drifts an invisible archive, fragments of old news reports, music, sports broadcasts, scientific experiments, conversations between spacecraft and mission control, messages we never imagined anyone else might hear. If an astronomer on a distant world happened to possess an extraordinarily sensitive radio telescope, they might already know that, sometime in the 20th century, a small blue planet around an ordinary yellow star suddenly became noisy. Very noisy. For the first time in Earth's 4.5 billion-year history, one species began announcing its existence to the universe. Whether anyone is listening remains unknown. But the messages continue traveling anyway, patiently, silently, perhaps forever. Tonight, we follow humanity's oldest conversations into interstellar space, not to ask whether they will ever be answered, but to wonder what they might someday mean to someone unimaginably far away. Every civilization leaves behind traces. Ancient Egypt left pyramids, Rome left roads, the Maya left observatories carved from stone. Humanity's technological civilization has created something far stranger, an expanding sphere of invisible information. The moment Guglielmo Marconi successfully transmitted radio signals across increasing distances near the beginning of the 20th century, Earth quietly changed forever. For billions of years, our planet had been almost invisible against the cosmic background. Then suddenly, it began glowing in radio frequencies. To distant observers equipped with sufficiently advanced technology, Earth would no longer appear completely natural. Something unusual had awakened. At first, those signals were weak, simple transmissions carrying only limited information. As technology improved, the radio environment surrounding Earth became increasingly crowded. Broadcast towers multiplied, military radar swept across the skies, television stations filled the atmosphere with countless hours of programming. Every transmission leaked a tiny fraction of its energy into space. Most weakened rapidly with distance, yet none completely vanished. Light does not grow tired. Radio waves do not forget where they were going. They simply continue expanding outward. Imagine dropping a pebble into an absolutely still lake. Circular ripples spread across the surface. Now imagine that those ripples never fade. They simply grow larger forever. Earth's radio history behaves in much the same way. Every year, the expanding shell becomes 1 light-year larger. The earliest broadcasts have now traveled well beyond 100 light-years from the Sun. Along their journey, they have already passed thousands of stars. Many possess planets. Some may even host life. Whether any civilization has noticed remains one of the universe's unanswered questions. Ironically, modern Earth has become quieter than it once was. Earlier generations relied on powerful broadcast transmitters sending signals in every direction. Today's communications increasingly travel through fiber optic cables buried beneath oceans or along the ground. Cellular networks use lower power transmissions. Highly directional satellite links aim signals precisely rather than broadcasting them broadly across space. As our technology has become more advanced, our planet has actually become less conspicuous from afar. Future astronomers searching for Earth by its accidental radio leakage might find us surprisingly difficult to detect. Humanity's loudest era may already be behind us. Of course, humans have not relied only on accidental messages. Several times, we have deliberately reached toward the stars. Perhaps the most famous example occurred in 1974. Using the enormous radio telescope at Arecibo in Puerto Rico, scientists transmitted a carefully designed message toward the globular cluster Messier 13. The transmission lasted only 3 minutes. Encoded within it were simple mathematical patterns. The numbers 1 through 10, the basic chemical elements of life, a representation of DNA, a human figure, a sketch of the solar system, and the telescope itself. The message was never expected to receive a reply. Messier 13 lies about 25,000 light-years away. Even if another civilization immediately answered, the response would not arrive for roughly 50,000 years. The transmission served primarily as a demonstration of humanity's technological capability. Even so, for 3 brief minutes, Earth intentionally spoke to the galaxy. Then, there are the spacecraft themselves. Earlier tonight, we followed spacecraft quietly rewriting our understanding of physics through astonishingly precise measurements. Some of those same explorers now carry something even more enduring than scientific instruments. The Voyager 1 and Voyager 2 spacecraft each carry a remarkable artifact known as the Golden Record. Unlike radio waves, which spread and weaken over time, these records are physical objects. Golden phonograph discs protected inside aluminum covers, tiny time capsules built to survive the harshness of interstellar space for perhaps billions of years. Their contents are astonishingly human. Greetings spoken in dozens of languages, the sounds of wind, rain, birdsong, laughter, a baby's cry, footsteps, music from many cultures, images showing DNA, landscapes, animals, architecture, and ordinary people going about their lives. Not a record of governments, not a record of wars, but a quiet portrait of a living world. Carl Sagan, who led the committee responsible for creating the Golden Record, once described it beautifully. The spacecraft would almost certainly never be found. The records existed less as practical communication than as a symbolic gesture. A message in a bottle cast into a cosmic ocean. Not because someone was expected to discover it, but because hope itself was worth preserving. Voyager 1 has already entered interstellar space. Voyager 2 has followed. Long after their instruments fall silent, both spacecraft will continue drifting around the Milky Way for millions of years. Patient travelers carrying humanity's introduction to whoever or whatever may someday cross their paths. There is something profoundly moving about the scale of these journeys. Civilizations rise and fall. Empires appear permanent until history quietly proves otherwise. Languages evolve, borders shift, cultures transform. Yet a spacecraft no larger than a small automobile may continue sailing through the galaxy long after every nation that built it has disappeared. The Golden Records could easily outlive mountains, perhaps even continents. They may become the oldest surviving artifacts our civilization ever creates. Earlier tonight, we wondered whether intelligent civilizations exist elsewhere, whether the silence surrounding Earth hides countless unseen neighbors. Now another possibility emerges. Perhaps somewhere across the galaxy, another civilization once launched its own tiny messenger. Perhaps it too carries music, greetings, photographs, memories of oceans beneath an unfamiliar sky. Its creators may have vanished millions of years ago, yet their message continues traveling, still waiting, still hoping, just as ours does. The galaxy may already be filled with forgotten introductions whose authors never learned whether anyone listened. The chances of Voyager encountering another civilization are extraordinarily small. Space is unimaginably empty. Even among neighboring stars, the distances are immense. Voyager is not aimed toward any particular destination. It simply follows its quiet orbit around the center of the Milky Way. And yet, given enough time, impossible events slowly become less impossible. Millions of years, hundreds of millions, perhaps even billions. The universe is remarkably patient. There is another audience for these messages. Not extraterrestrials, but ourselves. Imagine future descendants discovering the Golden Record after humanity has changed beyond recognition. Perhaps languages have evolved beyond comprehension. Perhaps continents have shifted. Perhaps Earth itself has become unrecognizable. The record would speak across time as well as space. It would remind distant generations who their ancestors once were, what they valued, what they feared, what they loved enough to preserve. Sometimes messages survive not because they reach strangers, but because they eventually return home. Earlier tonight, we imagined future astronomers living beneath a sky where every distant galaxy had disappeared from view. Now, we discover that even if the visible universe grows lonelier, humanity's oldest messages will continue their journeys long after the stars we know have changed, long after the civilizations we imagine have risen and fallen. Those faint radio waves will still expand outward. The Voyagers will still drift silently through interstellar darkness. The Golden Records will still carry the sounds of rain, of laughter, of a heartbeat from one small world orbiting an ordinary star. Perhaps that is the most beautiful thing humanity has ever sent into space. Not proof of our intelligence, not demonstrations of technology, not declarations of power, but evidence of our curiosity, our music, our kindness, our desire to say hello before we knew whether anyone else was there. Every civilization hopes to be remembered. Perhaps ours will be. Perhaps it will not. But somewhere tonight, racing outward at the speed of light, are words spoken by people who have long since grown old, songs performed by musicians who are no longer alive, laughter that echoed briefly through a recording studio before beginning a journey that may last longer than Earth itself, tiny fragments of humanity, crossing the darkness one photon at a time, still introducing us to a universe that has not yet answered, and perhaps is listening even now. 12. The mysteries we may never solve. Every generation believes it is standing at the edge of the final discovery. There is always a feeling that the greatest questions are almost answered. That one more telescope, one more spacecraft, one more equation, one more breakthrough will finally reveal how everything fits together. Our ancestors once believed the stars were tiny lights attached to a crystal sphere. Then we discovered they were distant suns. We thought our galaxy was the entire universe. Then we found billions more. We believed space was empty. Then we uncovered invisible dark matter, mysterious dark energy, gravitational waves, black holes, and planets orbiting distant stars. Again and again, human knowledge expanded. Each answer opened the door to 10 new questions. And perhaps that is the universe's greatest surprise. The more we learn, the larger the mystery becomes. Today, humanity possesses telescopes capable of observing galaxies billions of light years away. We have landed robots on Mars, sent spacecraft beyond the edge of the solar system, detected ripples in space-time itself. Yet, some of the most fundamental questions remain exactly where they have always been. What is dark matter? What is dark energy? Why does the universe exist at all? What happened before the Big Bang? Are we truly alone? Will we ever know? Or are there some mysteries so deeply woven into reality that no civilization, no matter how advanced, will ever completely solve them? Tonight, our journey comes to its quiet conclusion, not with certainty, not with final answers, but with something perhaps even more beautiful. The realization that mystery itself may be one of the universe's greatest gifts. Throughout tonight's journey, we have wandered across extraordinary landscapes. We visited places where reality itself appears to bend. We listened to ancient light that began its journey before the first stars were born. We followed invisible structures quietly shaping entire galaxies. We watched distant worlds slowly disappear. We imagined civilizations forever separated by time. We traveled into a future where the night sky itself grows empty. And finally, we released humanity's oldest messages into the endless darkness between the stars. Each story revealed something remarkable, but together, they reveal something even larger. Every discovery stands beside another unanswered question. Take dark matter, for example. Earlier tonight, we explored the invisible architecture holding galaxies together. Astronomers can measure its gravitational influence with astonishing precision. Galaxies rotate too quickly to remain intact without additional unseen mass. Galaxy clusters bend light through gravitational lensing. The large-scale structure of the universe depends upon something invisible. The evidence is overwhelming. Yet, after decades of research, no one knows exactly what dark matter is. Entire underground laboratories search for particles that have never been observed directly. Powerful particle accelerators continue probing nature at unprecedented energies. New telescopes map its influence across billions of light years. Still, the invisible remains invisible. We understand what it does, not what it is. Then there is dark energy, perhaps an even deeper mystery. A century ago, most scientists assumed the expansion of the universe should gradually slow under gravity. Instead, observations revealed something astonishing. Expansion is accelerating. Some unknown influence appears to dominate the largest scales of reality. Today, dark energy is estimated to account for roughly 70% of the universe's total energy content. Think about that for a moment. Most of the cosmos appears to consist of something humanity cannot identify. We can observe its consequences. We cannot yet explain its nature. It is rather like feeling the wind without ever seeing the air itself. Black holes present another extraordinary puzzle. Einstein's equations describe them with remarkable accuracy. Astronomers have photographed the glowing material surrounding their event horizons. We have even detected gravitational waves produced when black holes collide. Yet at their centers lies a place where our current understanding reaches its limit. General relativity predicts a singularity, a region where density becomes infinite and the mathematics itself breaks down. Physicists generally interpret this not as proof that infinities physically exist, but as a sign that our theories are incomplete under such extreme conditions. Somewhere inside a black hole, quantum mechanics and gravity refuse to cooperate. The universe quietly reminds us that our greatest theories remain unfinished. Perhaps the oldest question of all concerns the beginning. Earlier tonight, we followed the oldest observable light back nearly to the birth of the cosmos. The cosmic microwave background allows us to glimpse a universe only 380,000 years old. Earlier than that, the universe becomes opaque. Beyond that curtain, our current observations cannot directly see. What happened before? Did time itself begin with the Big Bang? Or did something exist earlier? Some theories describe bouncing universes. Others suggest cosmic inflation emerging from quantum fluctuations. Still others imagine entirely different possibilities. At present, no single explanation commands universal agreement. The first page of cosmic history remains partly hidden. Then comes perhaps the most personal mystery: consciousness. The universe has spent nearly 14 billion years evolving. Eventually, somewhere on one small rocky planet, collections of atoms became capable of asking questions about themselves. Why? How does awareness emerge from ordinary matter? Can consciousness exist in forms completely unlike our own? Science continues making extraordinary progress in neuroscience. Yet subjective experience itself remains profoundly mysterious. Why should matter arranged in one particular way become capable of wonder? The universe produced galaxies with effortless abundance. Yet, the experience of simply looking at those galaxies may be one of its rarest achievements. Earlier tonight, we wondered whether intelligent civilizations exist elsewhere. Despite decades of searching, we still do not know. Every year, astronomers discover new planets. Some resemble Earth. Some appear capable of supporting liquid water. Some orbit stars billions of years older than the Sun. Yet no confirmed evidence of extraterrestrial intelligence has appeared. Perhaps life is common? Perhaps extraordinarily rare? Perhaps civilizations communicate in ways we have not imagined? Or perhaps the distances separating them remain too immense? The silence continues, and with it, the question remains beautifully alive. There is another possibility that scientists rarely ignore. Some mysteries may simply exceed the capabilities of any civilization. Imagine a fish attempting to understand galaxies, or an ant calculating quantum mechanics. Intelligence has limits shaped by biology, perception, and mathematics. Human beings naturally assume that enough time eventually solves every problem. Perhaps that assumption is mistaken. Some questions may require information forever inaccessible. Some phenomena may remain permanently beyond observation, not because nature wishes to hide them, but because reality itself imposes boundaries. Every map has an edge. Perhaps knowledge does too. And yet, history encourages humility. Again and again, humanity declared certain mysteries forever unsolvable: the composition of stars, the age of Earth, the existence of atoms, the nature of distant galaxies. Each eventually yielded to patient investigation. Mysteries that once inspired mythology became chapters in science textbooks. This does not guarantee every mystery will surrender, but it reminds us never to underestimate curiosity. The universe has repeatedly rewarded those willing to ask impossible questions. Now, perhaps that is why science differs so beautifully from certainty. Science does not demand complete knowledge. It welcomes incomplete understanding. Every unanswered question becomes an invitation rather than a defeat. Every mystery becomes another path waiting to be explored. The greatest scientists in history rarely claimed to possess final answers. Instead, they asked better questions. Questions that future generations could continue exploring. Knowledge grows not because certainty expands, but because curiosity refuses to disappear. As our quiet journey through the cosmos draws to a close, it becomes clear that the universe is not simply a collection of stars, galaxies, and planets. It is also a collection of questions. Some have already been answered. Others are waiting, and perhaps a few will remain forever beyond the horizon of understanding. Surprisingly, that possibility does not make the universe smaller. It makes it infinitely richer. A completely solved universe would eventually become predictable, silent, finished. Instead, the cosmos remains wonderfully unfinished. There will always be another horizon, another mystery, another distant light inviting someone to ask, "What is that?" Perhaps millions of years from now, another civilization will continue asking those same questions. They may inherit better telescopes, more elegant mathematics, a deeper understanding of reality than we can imagine. Even then, they may stand beneath their own night sky and feel exactly what we feel tonight: wonder. Because wonder does not disappear when knowledge grows. It grows alongside it. Every answer simply reveals a larger landscape still waiting beyond. And so, before we leave the stars behind for tonight, remember this: the universe has never promised us complete understanding. It has only offered us the privilege of exploring. Every telescope pointed toward the heavens, every spacecraft crossing interstellar darkness, every child looking upward for the first time, every scientist quietly writing equations late into the night. They all participate in the same timeless conversation, a conversation that began long before humanity existed and may continue long after we are gone. The stars do not ask us to solve every mystery. They simply invite us to keep looking, to remain curious, to remain humble, and to find peace in the beautiful possibility that some questions may never have final answers. Because sometimes, the greatest treasure is not reaching the end of the journey. It is discovering that the universe is vast enough for the journey to never truly end. If tonight's journey through these cosmic mysteries helped you end your day with a little more wonder, consider subscribing, and I'll be here for our next quiet adventure among the stars.